This video will demonstrate some of the ROS capabilities. This is part 2 for Module 1, ROS Introduction, and we're going to just go through some of the basic commands we talked about in part 1 and kind of show how we can use those. Now, the first thing you need to do when working with ROS is create a workspace. In the video, we'll see that's called robotics underscore workspace, but I'd like you to call it master underscore workspace as shows in the note taker. So if we look into that folder, we just created the directory system that we use for our packages. And if we use cat-can-make, it will actually create all the other files we need for ROS. And all we're doing here is setting Python 3 as the default source for compiling our files. And all of these commands are in the note taker. So we can see it created a bunch of files. If we look in here, we have the build and devel directory. If we go into devel, there's a number of files. And the main one we need to look at right now is setup.bash. And that's what's, we need that ran every time we open up a new terminal so that it'll know to use our ROS workspace, or which workspace to use. So our master underscore workspace. So we can type the command source setup.bash, but we don't want to do that every time we open up a new terminal. So let's add that to our .bash rc file. And so this is some Linux code that you can use, a Linux command to use to add something to a file. And all the bash rc file does is that's what's ran every time a new terminal is opened. So when a new terminal is open, we can see here that the setup.bash will be sourced and will be good to go for using our workspace. And we can double check that by just looking at the ROS package path. And we can see that our robotics workspace, or for you guys, your master workspace, is added to the path. So that's all good. Now we have everything we need to make sure ROS is going to run correctly. So let's look in our source directory. Our source directory is where we'll store our packages. So let's create a package. And let's create one for our first in-class exercise that we'll do in class during lesson 2. And we can use the cat can create package command. Standard messages and ROSB, those will be our dependencies. And that will allow us to kind of have those built into our package. And if we look in here, you can see that package.xml file that we talked about earlier. Let's go back to our source directory, so our master workspace. And let's just make the project again. And we'll go through, and you can see there it's traversed and worked through ICE1. So it's got everything good to go. We're ready to start running our package. So we're going to keep that and set that aside for later for in class. But let's take a look at one of the built-in packages called TurtleSim. So every time you want to run ROS, you have to run ROS core. That's that master we talked about. So ROS core gets the master active and now facilitates all the other communication with all of our other package or nodes in ROS. So let's run a node. So the ROS run command takes the package name, which is TurtleSim, and then the node. So we ran TurtleSim node from the TurtleSim package. And we can see that if we take a look at what nodes are running, and we can use the ROS node list, we have TurtleSim, which we just ran, and then ROS out, which is our master. And we can get some information about these nodes. So if we do ROS node info, we can see what our node is doing. So it has a couple of public publishers and it subscribes. So remember, that's how it communicates. So it subscribes to the topic command velocity, or command vel. So right now we have one node, our TurtleSim, and then we have the master, so we have two nodes. So TurtleSim and our master. So let's add another node. So this is still part of the TurtleSim package, but this is going to be the node that allows us to use our keyboard to move the turtle around. So it's called turtle underscore teleup underscore key. And that allows us to use the arrow keys to move the robot. Or sorry, not robot, the turtle. Additionally, we can create another turtle node. and we could just rename it to something unique. So let's, again, turtle sim package, the turtle sim node, which is just that turtle altogether. Then we can just update the name, and let's just call it Gimli's turtle. And you can look over there, now we have 2 turtle nodes. So if we take a look and see what nodes are running, and then since both nodes are, we'll talk about that in a minute here. So let's look at what nodes are running. So now we can see we have Gimli's turtle, we have the regular turtle, we have the ROS out, which is our master, and then we have Teleop turtle, which is our keyboard controller. So let's look at what Teleop turtle is doing. So it's just a publisher, it's not subscribing to anything, and it's publishing to command vel. So there's that command vel, which the turtle is a subscriber. So if we want to look at how this communication is working, we can take a look at the RQT graph. Let's pull that up real quick. All right, so we have our Teleop turtle, which is a keyboard, and then 2 turtle nodes, which are the 2 boxes there showing the turtles. And each of those nodes are communicating over the command vel topic. So we can see Teleop's publishing on the command vel topic, but Turtle Sim and Gimli's turtle are both subscribing. And so when I move or hit one of the keys, both turtles will move since they're both subscribing to the same message or same topic. So we can get some information about that topic, so that command vel topic. So we do ROS topic list, that's all the topics that are currently communicating. Some of them are in the background a little bit more, so like the pose and the color sensor, those are used to kind of bring up the picture of the turtle. But we can also we can look at that information of the information passed over that topic. So if we take ROS topic echo, we can and then the topic that we're interested in, we can see what is the actual information passed. So we can here you see XYZ angular and XYZ linear. So as I'm clicking the keys, it's going to either go forward X or it's going to turn with Z, and then we can update our RQT graph, and we see now another topic, which is that topic, that echo that you in the bottom left corner. So since we're also sending the topic information to that echo, we see that in the RQT graph. And we can look at the ROS topic list. There's 1 publisher command vel, which is our keys, and then 3 subscribers, which are the 2 turtles and then our echo in the bottom left corner. So let's get a little bit more information about that command vel topic. So now we can learn a little bit about the messages sent over the command vel topic. So you can see here it's a geometry message of type twist. And if you Google that, you can get some information about it. But we can also just use ROS message show. So that last command showed a little bit of some Linux pipelining capability. So I can take the output of one command and pipe it using the vertical slash to a new command. So that's just the same as typing, that second one, ROS message show geometry messages twist. And we can see here that we have 6 floats, XYZ linear and XYZ angular, and that's what it's expecting over that topic. And we can actually publish a command over that topic now that we know the information. So we want to publish one instance of the command vel topic type message of a geometry message twist. And then we can throw in the XYZ values. So we're going to throw in a 2 on the X and then a negative 1.8 on the Z. So it should kind of arc at it forward and turn right at the same time. So kind of making a circle. So let's take a look at that when I send that message. And since we only sent one message over the topic, it only went for a few seconds, but we can update that publish command to just continuously send by using the -R flag. And now we can see the turtles are just going to go in a circle continuously. If if we update our Qt graph, we have a new publisher on the the command-vel topic. So that we had our keyboard still there, and then now our publish command in the top left of that, our Qt graph, is also sending information. And then still our 3 subscribers, the 2 turtles, and then this bottom left echo. The interesting thing with ROS and subscribers and publishers is if I use the keyboard, you can see the turtles turned. So the subscribers don't care who's publishing the message. They just are looking at the command-vel topic. And so if my keyboard's changing or the script or command is changing, it doesn't care. So we can see here there's 2 publishers now and 3 subscribers. So that could be an issue if you have multiple sensors trying to tell the robot, hey, there's something in front of you. Who doesn't know who to listen to and when to listen? All right, so we can clean up some of the stuff. So let's close some of these publishers. So now we're back to just our keyboard, and we got rid of one of our the echo command. So now we only have 2 subscribers, and we can see that here. So in the RQT graph, we now have 1 publisher and 2 subscribers. Let's talk quickly about services. So services are those request and response type of messages. So we'll see here, if we look at the turtle sim node, what services it operates. So there's a clear service and a spawn service. So those are the 2. There's a number of others, but those are the 2 we're going to look at. And we can get more information on those as well. So let's look at what type the clear service is. So it's an empty type. And you can imagine that if you clear, you don't really need any kind of response or anything. You just want to clear the screen maybe. So so we know it's a standard service empty, but we can take that type, pipe the response to ROS serve show, and that's going to just show us some information about that type of message. So let's call the clear command and see what happens. And we can see it just cleared the path. And we can take a look at the spawn service now. And try to get some information about that. What type is it? So it's a turtle sim spawn, so that's unique to turtle sim. And we can again pipe that response to our ROS service show command. So we're taking the result and then passing that to the ROS serve show, which would be the same as this command here if we took ROS serve show turtle sim spawn. And we can see here, so you have X, Y, theta, and a name. That's the 3 messages that, or 3 things that the client has to send in the request. And then the response from the server is just the string name, so below. So you can see here, I called the spawn with X, Y of 2, 2, a theta pointing at 0.2, and called it Gimli's turtle 2. And then the response I got was the name, which is Gimli's turtle 2. And we can see this again with Gimli's turtle 3. I highly recommend you take some time to play around with those commands in the turtle sim node. So again, the turtle sim package, and then you have the turtle sim node with the turtle teleop key controller. You can use ROS topic-h or ROS node-h to get more information on other commands that exist within those ROS node and ROS topic commands. So play around with it. Also, you'll take a look at the ROS tutorials. That's the main homework for today. It'll walk through some of the same stuff we did today, but go into a little bit more detail. So check it out. Have fun.